Binomial expansion questions. Question 1. Expand and simplify the following binomials. The easiest way to expand and simplify these is to use Pascal's triangle. So first draw Pascal's triangle. A. Because n is equal to 5, write down the 6th row of Pascal's triangle. 1, 5, 10, 10, 5, 1. Now write down the powers of C. C to the power of 5, C to the power of 4, C to the power of 3, C to the power of 2, C to the power of 1, C to the power of 0, which is 1. Now write down the powers of n. N to the power of 0 is 1. N to the power of 1, n squared, n cubed, n to the power of 4, n to the power of 5. Now multiply across each row to find the final expansion of c plus n to the power of 5. So the expansion is c to the power of 5 plus 5c4n plus 10c cubed n squared plus 10c squared n cubed plus 5c n to the power of 4 plus n to the power of 5. B. Because n is 7, highlight the 8th row of Pascal's triangle. Now write down 1, 7, 21, 35, 35, 21, 7, 1. Now write down the powers of P. P to the 7, P to the 6, P to the 5, P to the 4, P cubed, P squared, P to the power of 1, P to the power of 0 is 1. Now write down the powers of minus r. So you've got minus r to the 0, which is 1, minus r to the power of 1, minus r squared, minus r cubed, minus r to the power of 4, minus r to the power of 5, minus r to the power of 6, minus r to the power of 7. Now multiply each row. So we get p to the power of 7 minus 7 p to the power of 6 r plus 21 p to the power of 5 r squared minus 35 p to the power of 4 r cubed plus 35 p cubed r to the power of 4 minus 21 p squared r to the power of 5 plus 7 p r to the power of 6 minus r to the power of 7. Question 2. Extend and simplify the following binomials. Again, the easiest way to do it is to use Pascal's triangle. A. Expand 3c plus n to the power of 5. Because n is 5, highlight the 6th row of Pascal's triangle. Write down the 6th row. 1, 5, 10, 10, 5, 1. Now write the powers of 3c. So you get 3c to the power of 5, 3c to the power of 4, 3c cubed, 3c squared, 3c to the power of 1, 3c to the power of 0, which is 1. Now write down the powers of n. So you get n to the power of 0, which is 1. N to the power of 1, n squared, n cubed, n to the power of 4, n to the power of 5. Now multiply across, giving 243 C5 plus 405 C4n plus 270 c cubed n squared plus 90 c squared n cubed plus 15 c n to the 4 plus n to the 5.
Part B is a numerical question, but done in exactly the same way. So expand root 2 minus 1 to the power of 4. Because it is to the power of 4, highlight the 5th row of Pascal's triangle. Now write down the values. 1, 4, 6, 4, 1. Now write down the multiples of the first term. So it's root 2 to the power of 4, root 2 to the power of 3, root 2 to the power of 2, root 2 to the power of 1, root 2 to the power of 0 is 1. Now write down the powers of minus 1. So it's minus 1 to the power of 0, which is 1, minus 1 to the power of 1, minus 1 to the power of 2, minus 1 to the power of 3, minus 1 to the power of 4. Now multiply across to get 4. Minus 8 root 2, 12. Minus 4 root 2, 1. Add the terms up to give a final expansion of 17 minus 12 root 2. Question 3. Find the indicated term in the following expansions. A. The term with x squared y squared in the expansion x minus y to the power of 4. Because n is 4, we want the 5th row of Pascal's triangle. Because we are dealing with y squared, r is equal to 2. So we want the third term in the expansion. So that is 6. Now we can put 6x squared y squared. B, the term with x cubed y squared in the expansion 2x plus y to the power of 5. Because n is 5, we want the sixth row of Pascal's triangle. Because y is squared, we want the third number in the row. So we want 10. Now we can do the rest of the expansion. 2x is cubed, y is squared. Multiply out, we get 10 times 2 cubed is 8, x cubed y squared, which is equal to 80 x cubed y squared. C, the term with x to the power of 4 in the expansion 2x plus 3 to the power of 6. Because n is 6, we want the seventh row of Pascal's triangle. Because x is to the power of 4, to make 6, y must be to the power of 2. That means r is 3. We want the third number in the row. So we can write 15. Now expand the others. 2x to the power of 4. 3 squared. Multiply out, we get 15 times 2 to the power of 4 is 16. X to the 4 times 9, which when you multiply out comes to 2160 x to the power of 4. Question 4. The third term in the expansion of 2x plus p to the power of 6 is equal to 60x to the power of 4. Find the possible values of p. From the question, we know that n is equal to 6. Because we are dealing with the third term, r is equal to 2. Therefore, we can write 6 choose 2, 2x to the 6 minus 2, p to the 2. If we expand this, we get 6 choose 2 is 15, 2 to the power of 4, x to the power of 4, p squared. We know that that is equal to 60 x to the power of 4, which is equal to 240 x to the power of 4 p squared, which is equal to 60 x to the power of 4. Because x to the power of 4 is on both sides, we can cross it out. Therefore, we got 240 p squared is equal to 60. So p squared is equal to 60 over 240. So p squared is equal to 1/4. So p is equal to plus or minus a half.
Question 5. The third term in the expansion, 3x minus p to the power of 5, is x cubed. Find the possible values of p rounded to 3 significant figures. If this is the third term, r is equal to 3. N is equal to 5. Therefore, in the expansion, we get 5 choose 2, 3x cubed minus p squared. 5 choose 2 is equal to 10. 3x cubed is equal to 27x cubed minus p squared is equal to p squared. We know that that is equal to x cubed. Because x cubed is on both sides, we can cancel. So we are left with 270 p squared is equal to 1. So p squared is equal to 1 over 270. So p is equal to plus or minus the square root of 1 over 270. Therefore, p is equal to plus or minus 0.0609 to 3 significant figures. Question 6. The fifth term in the expansion of 2x plus p to the power of 7 is equal to 7 over 250 x cubed. Find the possible values of p. Because it is the fifth term, r is equal to 4 and n in this case is equal to 7. So our expansion will be 7 choose 4, 2x cubed times p to the power of 4. 7 choose 4 is equal to 35. 2x cubed is equal to 8x cubed. P to the power of 4 is p to the power of 4. And we know that that is equal to 7 over 250 x cubed. Therefore, we get 280 p to the power of 4 is equal to 7 over 250. Therefore, p to the power of 4 is equal to 7 over 70,000. P to the power of 4 is equal to 1 over 10,000. P is equal to the fourth root of 1 over 10,000. So P is equal to plus or minus 0.1. Question 7. Find the term containing x to the power of 10 in the expansion of 5 plus 2x squared raised to the power of 7. In this question, n is equal to 7. So we can write 7 choose r, 5 to the power of 7 minus r, 2x squared to the power of r. That is equal to x to the power of 10. We can now solve for r. The only way to get x is x squared raised to r, which is equal to x to the power of 10. So x to the power of 2r is equal to x to the 10. 2r is equal to 10. R is equal to 5. Now we can work out the coefficient of x to the power of 10. So we've got 7 choose 5 times 5 to the power of 7 minus 5 is 2. 2 to the power of 5, which is equal to 21 times 25 times 32, which is equal to 16,800 x to the power of 10. Question 8. Find the term containing x to the power of 12 in the expansion of 3 minus 2x cubed raised to the power of 6. N is equal to 6. Therefore, we can write 6 choose r. 3 to the power of 6 minus r minus 2x cubed to the power of r. This is equal to x to the power of 12. So x cubed raised to the power of r is equal to x to the power of 12, giving r is equal to 4. We can now substitute r equals 4 to find the coefficient of x to the power of 12. So we've got 6 choose 4. 3 to the power of 6 minus 4 is 2. Minus 2x cubed to the power of 4. 6 choose 4 is equal to 15. 3 cubed is equal to 9. Minus 2 to the power of 4. This gives 2,160 x to the power of 12. Question 9a. Find the term containing x to the power of 12 in the expansion of 3 minus 2x cubed raised to the power of 7. In this example, n is equal to 7. Therefore, 7 choose r. 3 to the power of 7 minus r minus 2x cubed to the power of r. Expanding to find r, x cubed to the power of r must equal x to the power of 12, giving r is equal to 4. Substituting r equals 4 gives 7 choose 4. 3 to the power of 7 minus 4 is 3. Minus 2x cubed to the power of 4. 7 choose 4 is equal to 35. 3 cubed is equal to 27. Minus 2 to the power of 4 is 16. X to the power of 12. Multiplied out gives 15,120 x to the power of 12. Question 9b. Find the term containing x to the power of 12 in the expansion of 3x to the power of 4 minus 2, all raised to the power of 6. In this example, n is equal to 6, giving 6 choose r, 3x to the power of 4 raised to 6 minus r, minus 2 to the power of r. Therefore we get x to the power of 4 raised to 6 minus r must equal x to the power of 12. Multiplying out, we get x to the power of 24 minus 4r is equal to x to the power of 12. So 24 minus 4r equals 12. So 4r equals 12, r equals 3. Substituting back in, we get 6 choose 3, 3x to the power of 4, 6 minus 3 is 3, minus 2 to the power of 3, giving 20 times 27 times minus 8 x to the power of 12, which is equal to minus 4,320 x to the power of 12. 9c. Find the term containing x to the power of 12 in the expansion 1 plus 2x squared raised to the power of 8. In this question, n is equal to 8, giving 8 choose r, 1 to the power of 8 minus r, 2x squared to the power of r. This has got to equal x to the power of 12. Therefore, finding r, we've got x squared to the power of r must equal x to the power of 12. So x to the 2r equals x to the power of 12, so r is equal to 6. Substituting back in, we get 8 choose 6, 1 to the power of 8 minus 6 is 2, 2x squared to the power of 6 equals x to the power of 12, which is equal to 28 times 64 x to the power of 12, which is equal to 1,792 x to the power of 12. Question 10. The coefficient of x in the expansion of x plus 1 over a to the power of x squared, all raised to the power of 7, is 7 over 3. Find the possible values of a. In this expansion, n is equal to 7. I'm going to slightly rearrange the question to give me x plus 1 over a x to the minus 2 to the power of 7. Therefore, I get 7 choose r, x to the power of 7 minus r, 1 over a to the power of r, x to the minus 2 to the power of r, and this must equal x to the power of 1. To find r, I get x to the power of 7 minus r, x to the minus 2 to the power of r must equal x to the power of 1, giving 7 minus r minus 2r equals 1, r equals 2. Substituting back in gives 7 choose 2, x to the power of 5, 1 over a squared x to the power of 4, which is equal to 21x over a squared, and we know that must now equal 7 over 3x. Therefore, 7a squared is equal to 63. 9 is equal to a squared, so a is plus or minus 3. Question 11. A. Expand x minus 2 to the power of 4 and simplify your result. Because n is 4, we want the fifth row of Pascal's triangle, which is 1, 4, 6, 4, 1. Expanding x, we get x to the power of 4, x to the power of 3, x to the power of 2, x to the power of 1, x to the power of 0 is 1. Now expanding minus 2, we get minus 2 to the power of 0 is 1. Minus 2 to the power of 1, minus 2 squared, minus 2 cubed, minus 2 to the power of 4. If we expand that, we get x to the power of 4 minus 8x cubed plus 24x squared minus 32x plus 16. Part B. Find the term in x cubed in the expansion 3x plus 4 times x minus 2 to the power of 4. In this question, we start with our expansion for x minus 2 to the power of 4, which is x to the power of 4 minus 8x cubed plus 24x squared minus 32x plus 16. We now multiply that expansion by 3x plus 4. So we want to know in that expansion which terms will give us an x cubed. Well, if we multiply 4 by minus 8x cubed, we will get minus 32x cubed. That is a term in x cubed. Also, if we multiply 3x by 24x squared, which is equal to 72x cubed, we will also get an x cubed term. If we add those two terms together, we will get 40x cubed. That is the term we want. Minus 40. Question 12. A. Expand 2x minus 1 to the power of 5 and simplify your result. Because n is 5, we want the sixth row of Pascal's triangle, which is 1, 5, 10, 10, 5, 1. Now we can expand. We get 2x to the power of 5, 2x to the power of 4, 2x cubed, 2x squared, 2x, and anything to the power of 0 is 1. Now expand our second term, so we get 1 to the power of 0, which is 1, 1 to the power of 1, 1 squared, 1 cubed, 1 to the power of 4, 1 to the power of 5. If we multiply that out, we get 32 x to the power of 5 minus 80 x to the power of 4 plus 80 x cubed minus 40 x squared plus 10 x minus 1. Part B. Find the term in x cubed in the expansion x minus 3 times 2x minus 1 to the power of 5. In this question, we first start with our expansion for 2x minus 1 to the power of 5, which is 32x to the power of 5 minus 80x to the power of 4 plus 80x to the power of 3 minus 40x squared plus 10x plus 1. Now we need all the expansions when that is multiplied by x minus 3 that will give us an x cubed term. Well, if we multiply minus 3 times 80 x cubed will give us minus 240 x cubed, then x times minus 40 x squared will give us minus 40 x cubed. Add those two terms together, we get minus 280 x cubed, the term we want. Question 13. Determine the constant term in the expansion of x minus 2 divided by x squared all raised to the power of 9. In this question, n is equal to 9. I'm going to rearrange the question slightly, giving me x minus 2x to the minus 2 raised to the power of 9. I can now substitute for n in the expansion, giving me 9 choose r, x to the 9 minus r, minus 2x to the minus 2 to the r. I know that that's got to give me some power of x to the power of 0. Expand out those that deal with x, giving me x to the 9 minus r to the x to the minus 2r. And that's got to equal x to the power of 0. So 9 minus r minus 2r is equal to 0. 3r is equal to 9. R is equal to 3. Substitute back in for r gives me 9 choose 3. X to the power of 9 minus 3 is 6. Minus 2 to the power of 3. X to the minus 2 to the power of 3. When multiplied out, gives me 84 times x to the power of 6 times minus 8 times 1 over x to the power of 6. They cancel, giving me a constant term of minus 672. Question 14. Consider the expansion of 3x squared minus 1 divided by x all raised to the power of 9. A. How many terms are there in this expansion? Because n is equal to 9, there are 9 plus 1, which equals 10 terms. B. Find the constant term in this expansion. Again, we need to find r. So n is 9, so we got 9, choose r. 3x squared, 9 minus r. 1 over x can be written as x to the minus 1 r. And we know that that's some value of x to the power of 0. Take out the terms that just have a x value. So we got x squared to the power of 9 minus r times minus x to the minus 1 r. So we got x to the 18 minus 2r, x to the minus r, which equals x to the 0. So we're 18 minus 2r minus r equals 0. So r equals 6. Substitute back in for r, giving us 9, choose 6. 3x squared, 9 minus 6 is 3, minus x to the minus 1 to the power of 6, which when expanded gives us 84 times 27, x to the power of 6 times 1 over x to the power of 6. They cancel out, giving us a constant term of 2,268. Question 15. The constant term in the expansion of x divided by a plus a squared divided by x raised to the power of 6, where a belongs to z, is 1,280. Find a. N is equal to 6, and I'm going to rearrange the equation to get xa to the minus 1 plus a squared x to the minus 1 raised to the power of 6. So you can write 6, choose r, xa to the minus 1, 6 minus r, a squared x minus 1 to the r. Taking out those that give you an x component, you get x to the 6 minus r times x to the minus 1 r, and that has got to equal x to the 0. So 6 minus r equals 0, r equals 3. Substituting back in, you get 6, choose 3, x to the a minus 1, 6 minus 3 is 3, a squared x to the minus 1 to the power of 3. So you get 6 choose 3 is 20. X cubed, a to the minus 3 times a to the power of 6, x to the power of minus 3. You know that that must equal 1280. The x cubed and the x to the minus 3 cancel. So you get a cubed is equal to 1280. So 20a cubed is equal to 1280. So a cubed is equal to 64. A is equal to the cube root of 64. So a is equal to 4.